right, so our goal today is that I can find a t-interval for what we say mu. And mu is the true average. Just like when we were dealing with p was the true proportion or true percentage. So we're now moving from categorical variables, where we would say the true percentage of something, to quantitative variables. And we talk about quantitative variables as the true average of whatever we're talking about. So we start initially with this problem about a bank manager. And a bank manager wants to know whether or not the bank's customer service agents generally met the goal of answering incoming calls within 30 seconds. An analysis of 241 call response times reveals that the average call time was 18.35 seconds with a standard deviation of 11.76 seconds. Find a 95% confidence interval for the true average call time of customer service agents. The first thing I'm going to do is I'm going to underline this. And the reason I'm going to underline it is you always want to use that last sentence or question to help you with the context. So when you interpret it, you'd say, I am 95% confident that the interval from blank to blank contains, and then use what the problem gives you to help with that context. People struggle with that context sometimes, so I think that can be a really helpful hint. Now, when we're constructing an interval, when you guys get to college, you'll have to go through the conditions why we can use what we're using. But for now, we're just going to go through the basic mechanics of how you get this interval. So the first thing when we find the interval, are we good? Yeah. Okay. When we find the interval, we want to identify the mean. The mean will always be given to you. Okay. So, so the mean will always be given to you, and you can see that the mean is given to you right here. It says with an average of 18.35 seconds. So just a friendly reminder that average and mean are the same thing. And when we identify the mean, we want to just identify it as x bar. And we identify it as x bar because it's about the sample. It's about the 241. Yeah. Just finished talking about the mean, and the mean is x bar. The mu is the true mean. The x bar is the mean for that sample of 241 callers. So already call response times are taking 18.35 seconds on average based off that sample. Is the bank manager happy with that statistic? No. He wants it to be 30 seconds. Could it be less than that? Would he be happy? Yeah. Yes, if it's over 30 seconds, though, he's going to be what? He's going to be mad, or she. It doesn't state the gender there. So we need to build an interval based off this so that it contains the truth. And how we do that next is we have to identify the n. Just a friendly reminder, the n is your sample size, so let's write that down. So part 2, n is equal to 241 call response times. That's our sample size. Next, we have to find something called our standard error. In our standard error, there's a formula for it. It is the given standard deviation divided by the square root of n. What we're doing right now is the standard error is predicting the population standard deviation. We don't know the population standard deviation, so we predict it using the standard error formula. We take the given standard deviation and they give us that standard deviation right here at 11.76. We take that 11.76 and we need to divide it by the square root of the total sample size, and that's 241. When I calculate that in my calculator, I should get 0.76. Let's always round to 2 decimals unless we need a third decimal. So if it was like 0.003. Do you have any questions so far? It's really just following directions. Hey, can I find the mean? Everything will be given to you. and then just typing some things in my calculator. All right, the next one is we need to find what we call the degrees of freedom. And the degrees of freedom we can call df. And it's equal to n minus 1. Okay, so we find our degrees of freedom. Degrees of freedom is a measure of spread. And so our degrees of freedom here, if we take n minus 1, it would be 241 minus 1. So we're going to say degrees of freedom and the degrees of freedom are really important as we try to establish what our critical value is. And I'm going to show you how to do that in a second. I'll give you a second to catch up. And just a friendly reminder, I'm taping, so if you can all stay nice and quiet.
Y minus 1.
Y minus 1, because right now we're dealing with one variable, the call response time. So when you guys get to college, that will change depending on what kind of distribution you're working on. Okay. All right. Any other questions right now? We're going to establish our critical value now. And our critical value is our T star, and you need your yellow chart for that. So if you want to glue that in, you can glue that in on the next page. Or you can just choose to keep it. It doesn't matter to me. The nice thing about gluing it in your notes is it's there and you're not going to lose it now as long as you keep your notebook. You can cut off the top parts with the little curve if you'd like, just to fit it in better. I'm going to pause the video right now. I'll let you guys kind of do this. So we need our degrees of freedom to establish what our critical value is. I'm going to show you how to establish that now. So I want you to look at your charts, and I already have it highlighted. Let me quick erase it so I can go through it with you. And here are all the different options for our critical values for a T interval. So when we're dealing with averages, not with proportions. With proportions, it's much easier, that Z star, and I gave you that chart, but it's also down here. So this infinite one, that's for our Z stars. We're not dealing with that right now. We're dealing with the T distribution. All of our critical values for the T are above the infinity here. And the reason that is as our sample size increases, it approaches the Z distribution. You'll talk a lot more about that when you get to college. For now, all you need to know is how to read this chart. And the first thing is that you need to recognize is just down here. You either highlight or circle these numbers right here are the different confidence levels you may have to find an interval for. So the first thing you want to say, okay, what kind of confidence am I having right now in my interval? So what does it state in our problem, in the blue sheet? What kind of confidence do we have? 95%. So right away then we know that our critical value, our T star, will be in this pink column. Okay, we know that our critical value will be in that pink column because we want a 95% confidence interval. And you can see 1.96, that was for our Z, for our P. So it's going to be anywhere above that number. Well, how do I find it? The next thing I need to look at is this column right here. And what do you notice it says? That's a terrible line. I'm going to redo it. What does it state at the beginning up there? What two letters do you see? DF, and DF is our degrees of freedom. So we want to look right now for our degrees of freedom, and our degrees of freedom are 240. Do you see 240 there?
No.
No. So what we do when our degrees of freedom are not listed in this column, we need to round down to the one that is listed. So we go until we see one that is listed when we round down. So 240 would be anywhere between 100 and 1,000, correct? We always round down. So we're going to go to 100, okay? Even though we're moving up on the chart, that is rounding down, correct? Okay, so I'm going to look at that column there at 100. And you can see right there where it crosses. My critical value is 1.984. So I want to quick just test you to make sure you understand the rounding down piece. What if my degrees of freedom was 35? What degrees of freedom would you use on the chart? You'd use 30. Very good. What if my degrees of freedom were 72? What would you use? Yes, you'd use 60. Very good. Okay, so everyone understands the rounding down piece? All right, let's make sure.
Is it always round down?
It's always rounding down so we can have a conservative estimate, we say. Okay? Now, let's write down our note there just to say, hey, round down. When the degrees of freedom is not listed on the chart. So what did I say? It was 1.984.
Yeah.
1.984. Okay, so our T star is equal to 1.984. That's our critical value. All right, the next step is to find our margin of error. And our margin of error has a formula, and that's equal to our standard error times your critical value. So we need to look for our standard error, and our standard error was 0.75, or 0.76, excuse me. I just need to erase a couple things here. Give me 1 second. All right, our standard error was 0.75, right? Or 76? 76, okay? Times 1.984. Can someone calculate that for me? I don't have my calculator handy. 1.51 then is our margin of error. Now that we have our margin of error, we're set to find our confidence interval. This goes much faster. Just the initial time that I introduce it, it's like, whoa, this takes a long time. It doesn't take that long. A lot of things are given to you. The average is given to you. The standard deviation, you're just looking at the chart and doing a few calculations. Okay, so what we need to calculate first here is our lower bound. That's our lower bound of our interval, and how we get that is we take our average, our X bar from step 1, minus our margin of error from step 6. So our average is 18.35 minus our margin of error of 1.51. And this gives us our lower bound for our 95% confidence interval. Can someone calculate that for me? 18.35 minus 1.51.
49.75.
Thanks, Mr. McCluskey. Trenton, did you do it? $16.84. Can someone confirm? All right. Our lower bound is 16.84. Once we get our lower bound, we need our upper bound. Our upper bound is the average plus the margin of error. So we take 18.35 plus 1.51. And then we're going to get 19.86. People in the last class were saying, where am I getting these numbers? 18.35 is our average. This comes from step 1. 1.51 is our margin of error. This comes from step 6. Now that we have our interval, we need to interpret it. So I'm going to type it so it looks a little bit nicer. And we've interpreted intervals before, and it's the same way. We start with, I am 95% confident that the interval from 16.84 to 19.86 contains, and this is where we go to what we underlined, contains the true average call time of customer service agents. I'm going to highlight a couple things. Why did I highlight those things? Yeah, those are fill in the blank. Okay, your confidence level may change. Your lower bound and your upper bound will for sure change. And then the last part is what comes from the problem. What are you trying to figure out? So it needs to be in context. Now, in your homework or on a test, they may ask you to do like a follow-up analysis. And what that follow-up analysis will be like would be if I would say, is the bank manager happy? So you have to look and say, well, what did the bank manager want? He wanted the calls to be within what? What does it say at the beginning? He wants it to be within 30 seconds. So would this bank manager be happy with his employees? Yes, and then you'd have to follow that up with the interval. Why? The upper bound of this interval is what?
Within 30 seconds?
Yeah.
Or at 30
Well, we're going to assume that within 30 seconds would be he wants it at 30 seconds or lower than that. Because if it's over that, then the customer's waiting, and customers don't like to wait, right? So this lower bound is 19.86, which is far below 30 seconds, okay, when you think about it in the grand scheme of things. 10 seconds, 11 seconds, that's a lot. So yeah, he's happy. If this upper bound was above 30, then he's going to say, hey, you guys, this could not be 30 seconds. You need to change what you're doing. Okay, questions? Excuse me. I'm going to stop it, and then I'll kind of talk about what we need to get done.